Welcome to this video on using approximations. Now, with binomial and Poisson distributions, the number in the sample could sometimes be quite large in practice, and this can make the calculations very difficult. Probably less so these days, but it still does. It's still sometimes easier to do an approximation. So that's where these kind of cases come in. So if the conditions are suitable, we can use an approximation. Okay, remembering that binomial does approximate to Poisson or normal distribution, although I do tend to find more of these go to the normal distributions, whereas obviously Poisson will only approximate to the normal distribution. So that's all you need to know for S2. Okay, I think the easiest thing to do, get stuck into a couple of examples and then give you a few to try. So let's go. Now with this question, there's actually a couple of other parts. This, what we're looking at, is actually part C within the question, but it's the bit with the approximation which we want to concentrate on. So we've got here a web server is visited on weekdays at a rate. So keyword there, the rate. Yeah, remember what that means? That means it's going to be Poisson. So at a rate of 7 visits per minute. Again, some more important information. In a random 2-minute period, on a Saturday the web server is visited 20 times. Using a suitable approximation, test at the 10% level of significance whether or not the rate of visits is greater on a Saturday. So we need to think about our null hypothesis. So for this one, H0 is going to be lambda equaling 14, isn't it? 7 visits per minute, 2 minutes, 14 visits. It was visited 20 times, and we need to test whether or not the rate of visits is greater on a Saturday. So that is what we're looking for. So H1, our lambda, is going to be greater than 14. So we're looking at a one-tailed test. Now I think it's important to write everything down. So don't forget, X is going to equal our number of visits. And obviously initially what we're kind of looking at is Poisson, and this being 14. But obviously I say obviously twice, then sound like an idiot, don't I? But in this case we're looking at the normal. Remember that with Poisson, the approximation is always going to be normal for our S2. So here now we are approximating with the normal, and of course these are both going to be 14. Now the other thing we need to remember is continuity correction as we're moving from a discrete data set to a continuous data set. So the probability that X is greater than or equal to 20. Actually, let me make a little change there. Let's actually call the normal one Y so we can remember what we're doing. So Y would be greater than, now if it's greater than or equal to 20, that would mean that it's greater than or equal to 19.5. Remember, with normal distribution it doesn't actually matter whether you use the greater than or a greater than or equal to, they're both effectively the same thing. So that's what we're looking at. At this point you have the option of using the tables or the option of using your calculator. Now my calculator, I just need to go menu, we're looking here, distribution, so number 7, we want normal CD. Now our lower value is going to be 19.5. Our upper value just needs to be very large to hit a lot of 9s. Our standard deviation, now this is going to be the square root of 14, and our mean will be 14. And there you see we get 0.0708. So this is equal to 0.0708. From here we can compare this with the 10%. So 0.0708 is going to be less than my 10%, isn't it? My 0.10. So therefore it's going to be significant. So something like this suggests that there is enough evidence to reject H0. I like to use words like suggest because, you know, with statistics and some of these things, there is no real definite answer, but it's, you know, it's highly likely. So that's what we're doing. First step. Now we need to make sure we write it in terms of the context of the question. So what does this mean in terms of the question? So that would be something like there is sufficient evidence to suggest that, and then now we're into the question. So the rate of visits is greater on a Saturday. Now, I've got that straight from the question. See it here? What we were testing is right here. So I'm just using the words already given to me in the question. I'm not reinventing the wheel. I'm not trying to write it any too differently. Just using those words. Okay? And that's it, quite straightforward. Now, before we jump on to another question, I will just do a little bit from kind of this point here, just for those of you who like to use the tables. So if you are that type of person that would prefer to use the tables, obviously from this starting point, we can move straight into our Z value. And Z is going to be obviously the X value. Don't forget about that continuity correction we talked about earlier. So X minus the mean over the standard deviation. Okay, and that should give us a value of 1.47. And here you can see I've got that 1.47. But, you know, it's not the same as what we just had out of our calculator. And obviously that is because you need to think of the graph. You know, what does this graph look like? Something like that. Obviously 14 in the middle. And there's our 19.5. And we want greater than. So you can see this is a 1 minus scenario, isn't it? This is actually 1 minus the probability that Z is less than 1.47, which is 1 minus 0.9292, which is 0.0708. So exactly the same as what we had here. And then, of course, at this point, we would just carry into what we're doing at this point. So, you know, you can use the tables. They're not too difficult. And, you know, you can do them fairly quickly, but obviously it is a little bit quicker in your calculator. Just make sure you put down enough of your steps. So again, this question is a part of another question. So this is actually the part B. There's nothing needed from the first part here, but let's get into it. So I'm going to skip through bits of it, but we got 20% customers bought sandwiches before this refurbishment. So that's looking at a probability. And look, we're looking at n as well. So we are looking at a binomial expansion initially. Okay. So I can see that this will be, n would be 120, won't it? And p would be, in this case, 0.2. So let's get into our hypotheses. So H0 is obviously p equaling 0.2. Expecting it to stay the same. Shopkeeper believes it's increased, so we're looking for p being greater than 0.2. So again, we are looking at a one-tailed test. Now here comes the little bit of the problem. Which approximation do we use? So binomial, obviously we can approximate with Poisson, or we can approximate with normal distribution. Now if you remember correctly, with Poisson, n is large, p is small. Well, n is large in this case regardless. P is small, is 0.2 small. If we're going to approximate with normal, we want p to be close to a half. However, we do have that little trick, and it's all kind of, as well, don't forget it's based on, or a big part of it is based or linked to, the use of tables and the limits that we have as well. So quick way of obviously doing this, I can't remember if I showed it on a previous video. I would have think so, but just multiplying these two together, and if this is larger than 10, we're going to need to use the normal approximation. So that's one kind of quick way of doing it. So yeah, mean larger than 10, and that's where we go. So we are looking, as I said, at a normal approximation now. So that means let's use y for our normal approximation. That's terrible, sorry. And for this one, we're going to use 24, which obviously we worked out anyway, and 24 times 0.8, because it's obviously np multiplied by 1 minus p, and that gives me 19.2, and that is obviously the variance. There we are, just making a few changes. I actually did forget then, so don't forget, let x be the number who buy sandwiches. So let x equal the number who buy sandwiches. This was also very important a long time ago, especially using the tables, as not all the probabilities would show up and stuff. Obviously it's still quite important now, but in the past it was definitely something that you could swap around. Sometimes it was easier to do a problem with the number of customers who didn't buy sandwiches, for example. But these days it is just straightforward. So we know it's 31 is what we're looking at. So the probability that x is greater than or equal to 31. Now we need to apply our continuity correction. So this is going to be that y is greater than 30.5. Remember, as I've said a number of times, you can replace that with a greater than or equal to. Actually doesn't matter. Personally, I usually use greater than or equal to for these ones. I know I didn't in the last example, but I generally do, and I just use the less than when I'm going down, but it doesn't really matter. Now at this point we just need to jump into our calculators. You've seen this before, so I'm just going to skip to that value. So 0.06898, so let me rewrite it, 0.0690. So there we have it. It is slightly different to the value you'd get from the table. I believe if you are someone who does this on the tables, you should come up with 0.0694. And that's obviously down to the value of Z, which is rounded off in the tables. Now, at this point, we just need to compare that, obviously, with our significance level. So 0.0690 is less than our 10%. Obviously, if we had a 5% significance level, we would be greater than, but we're less than it. So there is enough evidence to support, rejecting H0. And obviously there's enough evidence to show that customers are purchasing more sandwiches, or you could say that the shopkeeper's claims are correct. I'll write it down now. And there we have it, what I basically said. So remember, first bit, just link to the numbers, initial, accept, reject, so on. Second bit then, context of the questions. So here, therefore, there's evidence to support the shopkeeper's claim. I could have actually stopped there. That should have been sufficient to get me all of the marks. But I have gone on just to clarify a little bit further with that there are more customers buying sandwiches. Okay, quite straightforward. So I've done one of each. I'll pick out a few of these from past papers and stuff now just for you guys to have a go at. And as always, I'll pop the answers at the end of the video.